Long time no see. Sorry because I haven't made face-to-face class because I want to give you time to watch the videos. So next week we are going to do the live WebEx class as well. Today just a very small recap of what you need to take note about test 1, and then next week we are going to go through one by one lah. Any questions that you would like to ask about chapter 2? Okay, before we start, do you have any specific questions that you would like to ask on chapter 2? Everyone okay so far? Do you understand chapter 1 and chapter 2 just by watching the videos? No, tak ada soalan. Kalau tak ada soalan, if you don't have any question, I will go straight to the specific questions that I would like to present you. Tak ada Okay, so then sekejap. Okay, first record. Share. Okay, can you see this PowerPoint? Yes, Okay, so I have looked into your quiz 1 result, quiz 2. So most of you got full mark for quiz 1, congratulations. However, for quiz 2, only one of you got full marks. Most of you got problems in question 1 and 2. So if you have problem in question 1 and 2, so that means for other question you will get wrong as well. So if you please read this question first. So the number of cars entering an industrial parking lot every morning at opening times is a random variable having a Poisson distribution with a mean of 4 per hour. So what does this mean 4 per hour? That means they have the average of 4 cars. 4 cars per hour. So that means this 4 is for the lambda of Poisson. Okay, this is the lambda for Poisson. And just want to inform you that the lambda for Poisson, it can be also in the form of decimal because the lambda is average, not the number of cars. Okay, so that means the lambda is the average of the number of cars, not specifically the number of cars. So it could be also like, for example, 4.5 or 3.5, something like that. So please don't get confused. If you see here, if it's already stated that the 4 per hour is for Poisson distribution, that means this 4 is the lambda for Poisson. Okay, so this is the lambda for Poisson. So that means your X is PO, lambda pula. Okay, like that. Okay, and then suppose X is a random variable representing the time in hours. Okay, so if you see here, we have the X, right? So the question 1, they ask you what is the suitable distribution for the random variable X. Okay, so that means they want to ask you what is the distribution for this X. So if we read here, X is a random variable representing the time in hours between cars. So most of you, some of you confused whether the X is for Poisson or exponential. So if you read here, maybe because we have here Poisson distribution, after that we have time in hours. Okay, so please read carefully. This X is for the time. So time is continuous. Okay, while Poisson is discrete. Okay, so since x is continuous, because time it could be in the decimal form, for example 1.5 hours, 2.5 hours, it is continuous. So therefore your x is exponential. Okay, so far understand tak? Okay, so this Poisson distribution is not indicate the distribution for x. This is just a general information. Okay, the one that refer to x is the time in hours between cars. So that's why your x is exponential. Okay. Another one is, okay, most of you confused whether the lambda for exponential, is it 1/4 or 4? Okay, this one is very important. Okay, the lambda for Poisson is the same with the lambda for exponential. Okay, and the mean for Poisson is the same like the mean for exponential. So the average for Poisson is also the same with the mean for Poisson. However, the mean for exponential is not the same with the lambda for exponential. The mean for exponential is 1/lambda. Okay, so that means for 1, your exponential is 4 because the lambda here, lambda for Poisson is 4, right? So that means lambda for exponential is also 4. So this should be your answer. Okay, class? While for this one, for 2, your mean should be 1/4 because it's from here. Your lambda is 4, so 1/4 for your mean. Okay, class? Understand? Understand, eh? Okay. So if you can do this 1 and 2, you can do next question. You should get the correct answer for the next one. Okay, next. Okay, next I'm going to go through some of the important things that you need to take note. Nampak tak? That you need to take note for this test one, eh? So if you look at this question, I won't solve this question with you. I just want to inform you what's the important parts on this question that you need to take note. So for example, for number 4, so for the number 4, the 2% is for the defective chips. Okay. Sometimes, so when you read the question, you need to read carefully whether the question asks you for the defective part or the non-defective part. Okay, because if the question asks you for the non-defective part, for example, so that means maybe your probability should be changed as well. Especially on chapter 2, this one is very important. Sometimes we just want to make student confused. We will ask questions that is opposing the probability given in the question. So please read the question carefully. Okay, and then for this question, for A, they ask you how to find the mean and the variance for the random variable x. Okay, they want you to show. They already gave you the value of 5.3 and 0.81. So how to find the random variable x for this A? So you need to remember how to find the mean and the variance for discrete. This one, I have already shown you the example in the slide. Okay, so this is the examples. Okay, so you use this formula to find the mean and the variance. Okay, you can try this question later. I will give you the slide later. How about this question 3? Okay, this question 3 is this one is the question for chapter 2. So please take note that the question can be mixed with the chapter 1 and chapter 2 probability. So if you confuse how to differentiate between the probability of population and the probability of sample, probability of sample is in chapter 2, probability of population in chapter 1. Okay, so for example, probability of in chapter 1, probability of population, for example, x less than 3. Chapter 2, probability of sample, for example, we have the x bar, please plus x bar. We have the x bar less than 3, for example. So the question can be mixed with the population and the sample question. So how to differentiate between them? So normally for probability of samples, normally we would say find the probability of the sample. Or sometimes in the statement they tell you to find the probability of the selected data, something like that. The probability of the data that is smaller than population. So normally for that question is for finding the probability of sample. So please read the question carefully. And another one is, for example, if you do the question for chapter 2, you want to differentiate between the mean of the population and the mean for the sample, because sometimes we did not directly say, for example, the mean of the randomly selected. No, sometimes we did not directly say. So how to identify? So for example, normally for population we say previously it is known that. So if you see this word, normally the mean and the variance for that word is for the population. Okay, and for samples, normally we have randomly selected, something like that. For here we have a random sample is selected at random. That one is for the sample. Okay. This one I already show you how to do this example 1. This one is for chapter 2. So starting on chapter 2, the probability in chapter 2 is all for normal distribution. Okay, even though here, for example, example 1, if you see here the number of customers arriving per hour follow a Poisson distribution. Even though in this question it stated the number of customers follow a Poisson distribution, but based on the central limit theorem, if the random samples of number of size is more than 30, so automatically that sample is normally distributed. Okay, so remember how to find the probability of sample mean for example 1. Wait, class. Okay, so we have here your distribution for x bar is n mu variance divided by n, right? So remember for your probability of sample, the value of mu, how to find the value of mu and the value of variance, for example, in this question, because in this example, they did not directly stated the value of variance, right? So use this list of formula. Okay, in your statistical table also have this formula. Okay, kejap ya. Okay, so here we have the mean for Poisson the mean for poison is lambda and the variance for poison is lambda. So here they give you the value of poison is 12, right? So that means your variance is also 12. Okay, so here your mean is 12 and here your variance is also 12. So just insert the value of your mean here. So your mu would be 12 and here your variance is also 12. Okay, class? Or if the question give you that the data follow binomial, so that means your mean and the variance should follow this formula, and then you sub in the value of mean of the and the variance of binomial into the distribution. Okay, and then to find the probability of distribution, just take the value from the random variable. Okay? So far, any other questions? Okay, please, okay. Please remember that for sample, it should be X bar. If you do X, it's wrong. It should be X bar. If you do X, that one is for population. And then, when you do the finding the probability of the distribution also, we have, for example, here first, we have the X bar, right? For example, X bar more than, jap. For example, X bar less than, okay, X bar less than 10 lah, for example, for this question. Okay, please class, don't forget to change the X bar into the Z. Okay, and then you have 10 minus 12 divided by, now your variance is 12 squared, right? 12 squared divided by 36, right? Oh no, 12 squared is 12, it should be 12 only, because your variance is 12. So you don't have to square root, because that one already a variance. Okay, don't forget this. Don't forget this to square the 12 as well. Because this 12 is a variance, not a standard deviation. Okay, if this one is a standard deviation, you just have to square root the number of size. But since the 12 is variance, so you have to square root both the numerator and denominator. So please don't make this mistake. Okay. So this one, the X bar, change the Z and also the square root of both denominator and numerator. And also the first thing that you need to do is distribution. First, because when I look at your past year test 1, I have already checked your past year test 1. Most of you did not most of you, only some of you, a few of you did not write the distribution for your population or for your population lah. That one is for population. Okay, so the first important part that you need to do is the distribution of your population. Then you find the probability of distribution, then you change the X into the Z, and then you find the area, the final answer. So there should be 4 steps that you should do. Okay? If no question, I will just proceed down. Okay, how about this question? Make sure you know when to use modulus or not. So for example, this B, what is the sample probability? So you see here the question asks you sample probability. So that means this one is for chapter 2, finding the probability of sample. That the mean number of customer in an hour from both banks will differ by more than 2. So for this part, how do we know whether we should use the modulus or not? Because when the one that I show you in the video, the question already specify, right, whether to use modulus or not. But for this one, they did not specify. So do you have any idea whether we should use modulus or not? Tahu tak? You vanish tahu tak?
Not sure, Doctor.
Not sure, but from your understanding, what you understand?
I think must use lah.
Why?
Because I think the value, if it becomes negative, then it's better to use modulus, right?
Not quite right. Okay, but it's a good try. Thank you, Ivanish. So for B, how to decide whether to use modulus or not? So for B, they did not specify you which one come first. They said both banks. So you did not know which one you should minus first. Either you should minus from A to B or B to A, right? You did not know which one to decide. So that one you need to use modulus. Okay? Okay tak? You vanish okay kan?
Yes, Doctor.
Okay. Another one. How about B? For B, do we need to use modulus? No need, because from B, they say the difference between the mean resistance for sample 1 and the mean resistance for sample 2 is not more than 0.3. So they specify that number 1 come first and then number 2. So that means 1 minus 2. You don't have to do the modulus. Okay. And also please take note the symbol for not more than. Okay. Not more than, the symbol should be what? Less and equal than. Okay. So please remember this inequality symbol. So some of you might confuse with the no more than, no less than, at least and at most. So please be careful on this. Okay. How about this one? Okay. So for B, the difference between A and B, right? So A comes first and then B. So there is no modulus. However, for C, the mean height of bounds of both types, okay, they did not specify whether A comes first or B comes first. So that means you have to do modulus for the C. Okay, make sure you know how to do the modulus. So for example, if X less than A, for example, so you have X less than A and another one, X should be more than negative A. Doctor, if the mean for X bar minus X bar 2 is negative, then we need to abs the mean. No need. That one is for distribution of or what? Because if that one is for distribution, then your the value of your Z score should be also negative. Sampling distribution. Yes, just let it be negative. Don't change it to positive value. Okay, because even though your mean for sampling distribution is negative, however, your probabilities would still be positive. Okay, so just let it be. And make sure if your, for example, if your sampling distribution is x bar minus x2, right? Make sure your probability should also be x bar minus x2. Okay? If you want to do probability of x bar 2 minus x bar 1, so that means you have to use the sampling distribution of x bar 2 minus x bar 1. Don't use this one. Use this one. Okay, so please be careful on this as well. Okay, kejap ya kelas. Okay, again on your modulus. Okay, this one is very important. I hope you can remember how to do the modulus. First, you just copy here x less than a, and then another one, x should be the opposite of the first one. Opposite, and it should have negative a. Okay, so when you make a draw, a timeline x, so we have here negative a and a. Negative a should be at the left side. So more than negative a and less than a. So the probability should be in between. Okay. However, if your modulus for x is more than a, so it should be x more than a and x less than negative a, right? So when you do the timeline, you have negative a and a, so x less than negative a and x more than a. So there is no in between between negative a and a. So you cannot do like this. This is wrong, okay? Because most of my students did this mistake. So I did not give them mark even though their answer is correct. So what you need to do is px more than a plus. Okay, you should plus px less than negative a. So please be careful on this as well. Okay, before I proceed to the next one, do you have any questions? No? Tak ada Okay. Okay. I think, wait, let me check. What should I tell you lagi? Okay. Okay. Yeah. Okay, if you have checked your e-learning, okay. Okay, kejap I have updated some information for your test 1 in your WhatsApp group. Okay. Okay, you open your WhatsApp group kan? In your WhatsApp group, I have already I tak bagi tahu lagi lah. Sekejap mana? Belum masukkan lagi. Okay. I have sent you another information in your WhatsApp group. So at the top of your e-learning, you will find this title, Test 1, 2020-2021, Semester 1. Okay. Here, I have already give you the links for the statement on plagiarism and academic dishonesty. So please complete this form as soon as possible. Do it before the exam. Okay, if you did not complete this form, you cannot enter the test 1. So I will check whether you have complete this form or not. And also, please download this answer script front page. Okay, please complete this form as well, the answer script front page. Write your name, your section number, and my name as well. Please spell my name correctly. And please do it well before exam as well. and attach this answer script front page with your answers later. Make sure you have the scanner to scan your answers and make sure your answers should be in the PDF format. We will give you an extra 15 minutes to scan your answer and submit the answer to the e-learning. Okay? And we have also attached the formula to this link. So this is the only formula that you can refer to do your test 1. Okay, class, and please be honest. Don't cheat. Don't discuss with your friends. As an engineer, honesty is very important, right? Okay, so please be honest with yourself in doing the test 1. And this is the link for your test 1 answer submission. Okay, so you will submit your answer in this link. So if you read these instructions, okay, please answer all questions on your A4 size paper. If you don't have A4 point, it's okay, as long as you send the file to me in the form of PDF. Yes, can, but then you have to send the PDF file to me lah. Okay. Make sure your writing is readable, and when you take your answers with camera, take the answers, jangan ambil take the answer, catch the answer and capture your image accurately. Don't make it blur. And also rotate your answers 90 degrees straight, so that I won't have to rotate my head while marking your answer. Okay, and then scan all complete solutions, including the front page, which is this one. This one. Okay. Compile everything and save in one PDF entitled this one. Your name, your metric number, your section, and your subject code. So you are section 40, remember class? Section 40. Upload the question within the 15 minutes time given. Okay, extra than 15 minutes, your answer will not be accepted. So if you have problem with internet connection, please PM me as soon as possible, so that I can give you another option to submit the answer to me. Okay, clear? Yes, Mohaimin. Mohaimin, do you want to ask question?
Yes, madam.
Yes.
Can you explain for our slide sampling distribution, example 9? Universal factory produce two types of tennis balls, type A and type B. Lebih ada confuse sikit lah antara B dengan D.
Which one? This one? Is it in this slide or no?
Bukan yang tu. Slide yang madam ajar.
Chapter 2.
Chapter tu.
Wait, chapter 2. Example what? Example 9 Sekejap
Bukan,
Nampak ke ni?
yang ni.
Okay, this one, which question?
Antara B dengan D tu.
B dengan D. Sekejap, I baca balik. The difference between is at most the difference. Oh, okay. For B, A minus B. For D, B minus A.
Dia just terbalik je lah dia punya ni
Betul.
So kalau modulus dekat C je lah kan?
Betul. Modulus dekat C. Modulus dekat C. Okay, so B, which one comes first? B, A comes first, right? So A minus B. For D, B comes first, right? So B minus A. For C, they did not tell you specifically A and B. They said both, right? So this one should be the modulus. Okay? Okay, any other questions? Tak ada? Okay, if no, let's proceed to your test 1. Okay, so this is the statement on plagiarism and academic dishonesty. So please fill this form. And this is your answer script for front page. So please write your name, matrix number, course code and name, section, lecturer's name and date. We have 6 questions for your test 1. So approximately maybe around 15 minutes per question. Okay, so make sure you use that 15 minutes only for one question. And also this question, this test 1 is subjective, so you need to write your answers on the paper. And this is the list of formula that we give you that you can refer for your examination. So we already give you the mean and the variance for each distribution. So you can use this to find your mean and the variance. Okay, so your exam is on 26 November, Thursday, and the time is 8:30 p.m. until 9:30 p.m. night, Malaysian time. Okay, so for those international students, make sure you come to the test at the Malaysian time at night. And there would be no retest, no repeat test. So make sure all of you come to the test 1. It is compulsory. So you only given 1 hour for your test and another extra 15 minutes to upload your answer. The coverage for your test 1 is chapter 2 and chapter 1. Yes, 6 questions. Betul tak? 6 questions 15 minutes Check balik. 10 minutes ke? 10 minutes, sorry class. Nasib baik you check. 1 questions, 10 minutes only Cukup masa. The questions not so complicated, it's very direct for your test 1, so you don't have to worry. And then submit your answer to the e-learning. Make sure you have the statistical table, so you can refer your statistical table and also the list of formula that I gave you in your e-learning. Okay. And further instruction about test 1, I will inform you later. Okay, do you have any other questions?
Untuk nanti submission test 1 bagi berapa minit?
Submission? Yang 15 minutes that I told you just now.
Oh, okay.
That one is to collect your answers, scan your answers and submit to e-learning, 15 minutes only. Okay? Yes, submit before 9:45 p.m. And please make sure you keep your answers with you until you got the marks. In case suddenly the answer is missing, right? So keep the answers with you. So do you have any other questions? How about the exercises in chapter 1? Can all of you do that? Tips? I don't think I have any tips. Just do the exercises in the slide and also your past year test. Make sure you understand how to do that. Make sure you understand the difference between binomial and negative binomial, your Poisson distribution and exponential, and also hypogeometric distribution. Okay, you need to identify what's the difference between the population and sample. Okay, the one that I explained to you just now, the previous slide, is the tips lah, are the tips. Okay, I will share you some of the past year questions. Oh, okay, I will give you the solution for quiz 2. Okay, so I have already checked your answer in for your past year test 1 for chapter 1, so you can check lah in Padlet. So okay class, no question? How about how about chapter 1? Let me see what we have here. We have chapter 1.5. So all of you have already done the exercises in this slide. How about this example 12? Did you know how to do example 12? Okay, I will upload the examples in your e-learning. The example are in chapter 2. Yes, some of the example are in chapter 2. What was that form link for? You mean the statement of honesty? Tajwar? That one is for plagiarism form. So you can have that link in your e-learning. So please check your e-learning. So everyone already got example 12B? Do you want me to explain or is it okay with you? You already got the answer, so I don't need to explain example 12B. So example 12B, so the question said, what is the probability that more than 4 calls have to be made before getting connected? Sekejap. Okay. So we have 4 calls, right? 1, 2, 3, 4, 5. So the question said that what is the probability that more than 4 calls have to be made before getting connected? Okay, so that means these 4 calls, okay, so that means this one, the 4th calls made is the 4th, the 4 calls made is the 4th calls that not get connected. Okay, so that means to find this probability, so that means you have to use the negative binomial lah. So your negative binomial would be 4. So here we are going to use the probability of not get connected. Okay, so that means we have the R is 4th false is the R, and your probability not get connected is 1 minus 0.05, which is 0.95. Okay, and your X is equal to 4 calls. So that means Px is equal to 4. And then 3C3 0.95 to the power of 4 and 0.05 to the power of 0, you will get the answer. Okay, Tajwa? So we have two methods to do this example 12B. So the first example is this one. The first method is this one. The second method is you can also do like this. P x more than 4. So I use x because the sampling distribution, the distribution for x is different. So the distribution for x would be x, b, and we have here 1, 0.05. Here we want to show that after more than 4 calls, okay, after more than 4 calls, here we will get connected. The first one here, we will get connected. So that's why we have the R is equal to 1. Okay, and connected is 0.05, right? The probability. So we are going to use this distribution to do this probability of x more than 4. So here we would have 1 minus px less and equal to 4. That means 1 minus px equal to 1 plus px is equal to 0 until px is equal to 4. So find the probability of px is equal to 1 until 4 using this distribution. So you can still get the same answer. So either the first method, either you find the probability around here or you find the probability around here. So this would be the first and this one would be the second. You still get the same answer. But the first one would be much easier lah, much faster. Okay, understand everyone? Okay. How about another one is okay, hypergeometry we already discussed before. Make sure you know how to do hypergeometry. Oh, this one is chapter 1.5. Another one is chapter 1.6. So many slides, yeah. Okay, another one. For this part. Do you know how to do this one? The A and B. No need to explain. I explain je lah kan. I will explain to you. For this one, okay. Okay. So the time between phone calls received by a telephonist is exponentially distributed with mean. With mean of 10 minutes. Okay. So please be careful. This is the mean for the exponentially distributed. So this 10 is not the lambda. Okay, so the formula for the mean of exponentially distributed is 1 over lambda, right? So here we have 1 over lambda is equal to 10. So that means your lambda is equal to 1 over 10, which is also equal to 0.1. So this is the lambda. So 0.1 is the time between call receive is, so that means here means the time, okay, between phone calls received by a telephonist is 0.1 per minute. Okay, 0.1 per minute. Per minute tau ni, this one is per minute. So now the question A is, what is the probability that there are no calls in 1 hour. So there are two methods of doing this A. You can use either the exponential or the Poisson distribution. So for example, by doing the exponential, we have, okay, change this 1 hour into minutes. So you can change this 1 hour into minutes, or you change the 0.1 per minute into hour. So I would change this 1 hour into minutes lah, much easier. That means Px more than 60. Okay. So we have here the formula of Px more than 60 is e to the power of lambda x, right? So your lambda is 0.1. Okay. And your x is 60. So we have e to the power of berapa? 6 eh? Kan? Okay, and then you will get the answer is 0.0025. Okay? Yes, correct. Oh, sorry, I forgot to write your distribution. So your x should be exponential 0.1. Okay? How about your B? How about using the Poisson distribution? You can also use Poisson distribution by, this one is 1 hour is for exponential. This no calls is for Poisson. No calls is discrete, right? It is not continuous because it is impossible for you to have 1.2 calls, 1.4 calls, and not impossible. So that's why this one is discrete. So that means your Y for Poisson is, remember the lambda for what? The lambda for exponential should be the same with the lambda for Poisson. So your lambda is 0.1. However, since this one is for 1 hour and this 0.1 is the lambda for 1 minute, but we have here is for 1 hour. So that means we have to times 60. Okay, so that means your Poisson is Poisson 6. Okay. So please be careful, even though the lambda for exponential and Poisson is the same, you have to look also into the time of the probability. Okay, so this is for Poisson. So now to find the probability of Poisson, so your Px, okay, now your x is discrete, no cos. So that means no cos is x is equal to 0 lah. So x is equal to 0, then you can use. Plus another important things, I noticed that some of you, you use, for example, Px less than 6. You use directly the formula for Poisson distribution. Cannot, class? You use, for example, here you use e negative 6, 6x divided by x. Cannot, this is wrong. This formula for Poisson is only when this one is equal to 6. Okay, so if you want to use this formula, so you have to change, for example, Px less than 6 into something that have the formula equal. For example, Px less than 6, right? We have, kejap 5, 6, so we have 6, etc. Okay, so that means you can use the statistical table directly, or you could also use Px is equal to 0 plus Px is equal to 1 plus until Px is equal to 6. Then you can use this formula one by one for x is equal to 0, 1 until 6. Okay, back again into this example. So Px is equal to 0 is also equal to e to the power of negative n plus negative 6. And then 6 to the power of 0 and divided by 0. And you will still get the same answer with A. Okay? Understand? Okay, class, no question, For B, what is the probability that there are not more than 4 calls within 1 hour? So this one you can use the Poisson, 4 calls. So Px less and equal to 4. And remember the symbol for not more is less and equal to. Okay, class eh? Understand? I think that's all. I mean the important exercise that I want to explain to you. How about the normal eh? Normal. Normal tak ada yang penting. Okay, good. I think that's the only exercise that might confuse you. Yang lain, I think should be okay, the other questions. This one should be okay. Chapter 2, do you have any question on chapter 2? No question for chapter 2? Not yet for now, okay? So please watch the videos and next week, tak apalah, we are going to have, can we have quiz on Sunday? No, on Monday, chapter 2. Okay, so chapter 2 we are going to have quiz on the single mean and the two population mean. So please be prepared on Monday. Okay, then I think that's all. Please fill in this attendance before we finish our class. So chapter 2, single mean and two population mean, the quiz. Okay, so please fill in this form. My name is Siti Rohani, not Nur Hafiza, so make sure you write my name correctly. Okay, I think that's all for today. Thank you. If you have any question, just ask in WhatsApp group. I will explain that.
The form got problem.
Oh, got problem eh? Wait eh.